So this is our 3D printer. It's stereolithographic. It uses a 405 nanometer 20 milliwatt laser, and this laser focuses on the top layer of the printing surface. So this 3D printable liquid is cured with the UV laser, and as the object begins to form, it sinks one layer at a time. So the z-axis goes down one step once the laser has completed the pass over the surface. So this whole chassis was originally part of an existing 3D printer that used this extruder. Fortunately, this broke, as many extruders do, because of the high heat, and we replaced it with the laser. We modified some of the stepper motors to have more torque, and then we created this little apparatus that would hold the build platform and make it lower and rise as the vat of liquid will lower and rise. And Jason's going to explain the code.
Alright, so in a previous course I wrote some code that will parse in the G code. The G code is the instruction language that the 3D printer runs on. The G code contains many points such as X, Y, and Z points, and just a text file that has all that data in it. And I wrote a program that reads in that file, parses the code, and draws the line that the path that the printhead would move in graphics. So for this project, we sought to take this code, remove the graphics from it, and replace the drawing functions with stepper motor functions to move a motor from one point to another. Unfortunately, this was a little more difficult than we thought it would be. So what we finally had to do towards the end is just directly control the motors to move in a square fashion. We move it back and forth, and each time it moves back and forth, the y-axis would move down, so it would draw a square. We'd increment the z-axis and move it down manually, and then draw another square. So we had to manually create we manually coded up a cube, but eventually we wanted to get the code to working to where we'll be able to read in G code, and anything we make in a CAD program we'll be able to print with. So that is the code here. We're going to demonstrate the functionality of the printer now. As you can see, we're just moving the laser back and forth across this, and where there's some resin down inside of here, it actually cures pretty fast. Even if it's high speed the laser's moving at, it still cures the resin plenty fine.
And because of the width of the laser, it is a lot less than that of the extruder, so you have the possibility of having a lot more precise objects being printed with a much higher resolution.
Yes. So if we were to look at this object right here, I'm not sure if you can see that from the camera, but tiny little lines on this is the quality of the print. You probably can't even see the lines with the camera, but the line resolution is very, very precise, very minute little lines. So with SLA, you can print a lot faster, a lot more precisely, and a lot more efficiently than with standard plastic extrusion printers.
And the way that we're controlling everything is through a Raspberry Pi Model B, and we're running it through a couple of Pololu stepper drivers that are hooked up directly to the stepper motors, and we're doing full steps, and as we had mentioned previously, we're just using the program to control everything, and that's it.